This video is going to be a review of solving systems of 3 equations and 3 variables using substitution. I just want to point out that this is just kind of illustrating that you'd have 3 terms on the left side most of the time and the constants on the right, and you're going to be seeing 3 different variables, and most of them are going to have 3 different terms versus the more simpler substitution and elimination that you do with the 2 equations and 2 variables. Our goal is to go from the 3 and 3 to the 2 and the 2 equations, 2 variables. And then finally, of course, use substitution or elimination on these 2 equations to get an answer. You can mix and match. So just to be really clear, we can go ahead and use substitution or elimination, and this is going to be a demonstration of just substitution, to go from 3 equations to the 2 equations, and then you can turn around and use either the same method. If you use substitution, you could turn around and use substitution to go to the solution, or you can mix and match. You can just switch from substitution to elimination. Let's go ahead and start with an example. Here we have 3 equations, and you notice they all contain the variables x, y, and z. Now, to demonstrate substitution, the first thing I'm going to do is I like to label my equations just so I sort of keep track of my work. This is a great idea. And when you do substitution, you want to isolate one of the variables, and so typically the best one is going to be one that either does not have a coefficient, such as this x in the first equation, and possibly the z in the first equation, or the next, and there's also the y in the second equation. Another option is always one that has just a negative 1 coefficient. So I'm going to go ahead and start with the first equation and isolate x. And I'm going to go ahead and label this a down here. And I'm going to rewrite that equation. But what I'm going to be doing is, I'm going to be, let me just rewrite the whole thing so you can see all the steps here. So this is just the equation as it is. And I'm going to go ahead and add 2y to both sides. And I'm going to go ahead and add the opposite of this plus z, which would make it minus z to both sides. And what that's going to do, that's going to give me a new equation which only has an x on the left-hand side. All of this goes away because I basically added opposites together. So the negative 2 and the positive 2 cancel out. The plus z and the negative z cancel out. And over here on the right, I'm going to bring down my 2y, my minus z, and my minus 4. And I can't combine any of them because they are not like terms. Now the beauty of this is I now have an isolated variable, an expression that is equal to it. And I'm going to take this expression that I'm basically putting a border around in pink, and I'm going to substitute that into the other 2 equations that I haven't used yet. And again, this was equation A, so I'm going to substitute 2y minus z minus 4 into equation B and C, and I'm going to be substituting it for the x. So let's start with equation B. I'm going to label it over here, and I'm going to write negative 4, but instead of x, I'm going to insert this expression here, 2y minus z minus 4. Okay, and I'm going to continue on with the rest of this equation. We got a plus y minus 2z equals 1. I'm going to go ahead and clean that up by using the distributive property, which means I'm going to take my minus 4, negative 4, and multiply it by all 3 of the terms on the inside of the parentheses. So I'm going to end up with negative 8y and a positive 4z. Negative 4 times negative 4 is going to be plus 16. And I've got plus y minus 2z, all still equal to 1. I'm going to combine my like terms, so my negative 8y and my plus 1y are going to give me negative 7y. My 4z and my minus 2z gives me plus 2z. And then I've got this plus 16 over here. I'm going to go ahead and subtract 16 from both sides, so that I'm going to end up with negative 15 instead of 1. Now I can go ahead and do the exact same thing, only I'm going to do it with equation C. Okay, I'm going to write it in blue. I'm going to take my 2x plus 2y minus z, I'm going to turn it into 2 times 2y minus z minus 4. Okay, and then I've got plus 2y minus z equals 10. I'm probably going to run out of space here. So let me go ahead and continue this up here. Using the distributive property, I'll have 4y minus 2z at minus 8 plus 2y minus z equals 10. Okay, so I'll clean this up a little bit. My positive 4y and my 2y are going to give me 6y. My minus 2z and my minus z are going to give me minus 3z. And then I've got my minus 8. Well, I'm going to go ahead and add 18 to both sides. That's going to take care of this 8. And I'll have plus 8, that's an equal sign. There we go. And it equals 18. Okay, so that was equation C. I'm just going to go and write C there. I'm going to go ahead and rewrite equation B, which is the pink one. Oh, actually, I wrote it in yellow down here. So I'm going to write my negative 7y and my plus 2z equals negative 15. And that was B. So I'm going to go ahead and use elimination. So here I'm switching from substitution, which is what I did previously, to go from 3 equations to these two variable equations. I'm going to go ahead and use elimination now to change these so that they are equations with opposite coefficients for the z. I like that one because it looks a little easier. The only way I can see to do this is to multiply the first equation by 2 and the second equation by 3. All right, so let me go ahead and rewrite the equation C in blue by using the distributive property of multiplying everything by 2. I'm going to have 12y minus 6z equals 36. Okay, and then I'm going to have multiply everything here by 3. I'll have negative, I'll make it yellow. There we go. So 3 times negative 7y is negative 21y. 3 times 6z is plus 6z. And then 3 times negative 15 is negative 45. So I can go ahead and add these together. And what I end up with is negative 9y, these two cancel out, equals negative 9. And then, of course, I can divide both sides by negative 9. I'll have y equals 1. So I'm going to go ahead and make a spot for my answer right here. This is going to be my x, my y, and my z. And I found my y. So now I'm going to go ahead and try and find I guess I'll just go ahead and try and find my z now. And I will use this equation right here in blue. So 12 times y, or 12 times 1, minus 6z equals 36. There we go. I'll subtract 12 from both sides. I'm going to get negative 6z equals 24. And if I divide both sides by negative 6, I get z equals negative 4. So I'm going to plug that in right here. And the next one, of course, I need is my x. So I can pick any one of these equations, a, b, and c, or any of the equivalent versions that I have. And since I'm looking for the x, I think I'll just go with the very first one, a. I'll rewrite a. And instead of y and z, I'm going to substitute the values that I know that they are. So it's going to be x minus 2 times 1 plus, instead of my z, I'm going to write negative 4 equals negative 4. I'm going to have x minus 2 minus 4 equals negative 4, or x minus 6 equals negative 4. And then if I just add 6 to both sides, I will have x equals 2. Now, the next step, I know you're not going to watch this video, but the next step would be to go ahead and, write the answer. It would be to try these out in all 3 of the original equations and confirm that they do work. And that is a step that you absolutely should do. I'm not going to do it in the video just because I'm not teaching how to do that, but I just want to remind you that you do need to verify your answer. If you have any questions, please just respond to this YouTube